From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
The Army Research Lab is the basic academic research institute for the Army, which supports, it's the bench level research unit that supports the rest of the development centers within the Army. Those development centers include Natick soldier systems, so they deal with anything that has to do with feeding or clothing a soldier, also tents and other things like that, parachutes, that kind of stuff. There's what's known as C5ISR, which is mostly communications and control, so any networking and communication devices. There's the Armament Center, which is obviously armaments. There's the Aviation Missile Center, Ground Vehicle System Center, and Chem Bio Centers. And I hope I didn't miss one there.
That was LJ Holmes. LJ is the Executive Director of Advanced Manufacturing at Harrisburg University of Science and Technology. LJ has many years of additive manufacturing experience, including time in the Army Research Lab. He continues to be active in maturing defense-related manufacturing projects through his work with Astro America as well. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to your show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials, qualification, or general additive manufacturing support, reach out to the team through our website or via email at info@3degreescompany.com.
LJ, thanks so much for joining the show today. I'm excited for your perspective and hearing your career story. So we always start kind of from the beginning, from the ground up with everybody, put some context on where you came from and kind of what got you on the path towards where you are now. So let's start with that. So where were you born? Kind of what were those early days running around like, and kind of getting you towards like working with your hands and making stuff.
Yeah, sure. Thanks for having me, Mike. I appreciate it. My name's Larry Richard Holmes Jr. Most folks call me LJ. I grew up in Chicago, went to high school in Atlanta, both major city kind of education. I went to undergrad in Daytona Beach, Florida. It's a great place to go to college. Embry-Riddle Aeronautical University. I went to study aerospace engineering. So that's my undergrad degree, with some math in there as well. I went to Embry-Riddle because I thought that I wanted to design aircraft. After I was there for a couple years and got through with my core classes and started really getting into aircraft design, pretty much found out that commercial aircraft designs haven't changed for a very, very long time. There wasn't really a lot of fun stuff going on. And so I thought about getting into automotive design instead. At the same time, I was bartending at a bar right across the street from the International Speedway while I was an undergrad. And of course, as you know, there's a lot of races that happen at the Daytona International Speedway, not just the Daytona 500. I was especially interested in the road course style races like America Le Mans. I was there, and a lot of race teams used to come in the bar right across the street after they got done with their hard day of work. And one day I was talking with one of the teams, one of the Audi teams that was in the bar, and they said, "Oh, hey LJ, I heard that you were an aerospace engineer." I said, "Well, not yet. I'm still in school, but yeah, I'm studying." They said, "Well, do you know anything about wind tunnels?" And I said, "Well, yeah, all I do is wind tunnel testing, and I build models for wind tunnels, that kind of thing." And they said, "Hey, we've got this data from some wind tunnel testing in Germany. Can you help us out with it?" And so I said, "Yeah, I'll give it a shot." And so they offered me a job over the summer to work on some wind tunnel testing data. And that ended up turning into working with Audi Sport North America for an entire summer. It was a lot of fun. Further on in my career, I actually worked with Volvo for a little while too, but mostly in working on aerodynamics. And I was able to offer some advice in aerodynamics early on, reading through some of the wind tunnel data that was, I'm not going to say it wasn't complicated. It was just something that I'd done a lot of. And apparently I finished it faster than they thought I would. They asked me what else I would work on. And I said, well, I have composites processing experience because I make composite, models for wind tunnels all the time. So, so I started working with the composites guys and ended up working on some really interesting design, aerospace, aero designs for some race cars. Had a really good time. I worked with Audi Sport North America during the 2000 Speed Vision World Championship. That was awesome. Worked on the Audi prototype R8 at the time when it was open cockpit vehicle in American Le Mans. It was a great time. Had a lot of fun. Tough work in the race industry. I love automotive racing, but it's traveling that much wasn't conducive to starting a young family, which is what I was trying to do. So,
so everything is like you have to go like place to place with a team, or do you have a centralized garage or like workshop too?
I was at the headquarters for down in Miami for this particular race team for maybe a week.
Okay.
And then 4 months on the road. So you do everything on the road. There's some really good stories out there. Historically, you could look at this race in Mosport in that 2000 time frame where we were with At Speed Racing. I'm sorry, with Champion Racing, racing the prototype R8, and there was a wreck. I won't name a driver, but there was a wreck on Mosport on the last lap that we were doing pretty well in, and just couldn't finish the race. Car got destroyed on the very last lap, and then we had 2 weeks to build a new car before we went to another racetrack. I think we were going to Mid Ohio, and so we had a what do you call it? Just a shell of a car that was really used for showing off and marketing, that kind of thing. People taking pictures beside it, but it was just a shell, no suspension, no transmission, no power, nothing. And so we had to turn that into a race car in 2 weeks, and that was a lot of fun. But no, there was no going home. It was work constantly for months and months at a time. Again, a lot of fun, but not conducive to starting a young family. And so after I finished that for that summer, I finished undergrad, and then I was recruited by the U.S. Army Research Lab. They were at the time building some lightweight composite armor for many different ground vehicles. And they were looking for somebody that had composites processing experience and automotive experience. And so I kind of fit the bill for them, even though when I went there to discuss the topic with them, I said, listen, making lightweight composite structures for automotive race industry, motorsports, is paper thin, and making lightweight composite armor is, foot thick. The materials and the manufacturing methods are totally different. But they said, well, we're glad you recognize that. Now you're going to come and learn how to do it this way. So that I ended up spending 15 years at the Army Research Lab. Great experience. A couple years in, I was working on through thickness reinforcement. For those of your listeners that are composites experts, they understand that composites and additive have similar issues with Z direction, laminar structures in general, right? And so I went to my boss and I said, hey, this is like 2003. I said, hey, there's this thing called 3D printing. You can make anything in 3 dimensions. It's going to solve all of our Z direction problems because I can make something in 3 dimensions, and we should get a 3D printer. And my boss at the time, Mick Marr, who's a former DARPA program manager as well, he said, well, why don't you, don't get too excited, LJ. Why don't you go do a lit review and, tell us exactly what our options are. So I came back, I don't know, 2 or 3 months later, and I said, turns out 3D printing is immature. You can't do anything with it. It's toys. Unless you want to make bobbleheads, you can't do anything with 3D printing. But I think that there is some future there for the Army. We really need to get involved in it. And so I had a few years there of fighting against the stream. That's just toys to make toys. That's not real research. We're not doing that for a couple years. And then I think in 2008 or 9, I had the Army's first program of record in research for additive manufacturing or 3D printing at the time. Small program, not even a full year funding. I think they were just like, we just want you to shut up and figure something out.
How did you first hear about 3D printing? Was it during your automotive days, or were in school?
No, actually, I didn't really hear about it at all during my automotive race days. But I did start hearing about it, some rapid prototyping when I wanted to make some models outside of college, actually. So I graduated in the early 2000s, but by 2003, I had started hearing about prototyping for, wind tunnel activities, some of my friends who were doing wind tunnel work. And so I just kind of started digging into it. And soon after that, it's the first time I met Chuck Hall from 3D Systems, who's the father of modern additive manufacturing. And I've had a great relationship with him since then, and he's been a great mentor. I didn't really know anything about 3D printing and jumped kind of feet first into it. But when I started that first program of record in 8 or 9, I forget which year it was, but we started working on something very interesting. I think it still got legs. It was futuristic at the time, using electric fields to align and orient particles in 3 dimensions in stereolithography. There are a few applications out there now since then. I think Bart Raymakers, who's formerly out of Utah and now at Virginia Tech, has used acoustic signals. And I think there's a company called Fortify that was Fortify 3D that has had some success using magnetic fields. I used electric field manipulation, but I think that ended up being the Army's first patented additive manufacturing technology. I'm not sure, but that's what I've heard. And from there, I started developing optimizing processes for additive manufacturing materials and technologies for Army use. And
so with
go ahead, Mike.
With that, maybe take a step back to the extent that you can in terms of like, what's Army Research Labs, general remit? Like what are they trying to do as a part of the Army? And then kind of how does new technology like additive kind of fit into that? Is it like purely manufacturing, like looking ahead of like, okay, hey, we've got this sort of vehicle set and we need to support manufacturing of that? Or are they doing actual manufacturing? Like where does it kind of like how broad is ARL?
Sure. Thanks. Yeah. So the Army Research Lab is the basic academic research institute for the Army, which supports, it's the bench level research unit that supports the rest of the development centers within the Army. Those development centers include Natick soldier systems. So they deal with, anything that has to do with feeding or clothing a soldier, also tents and other things like that, parachutes, that kind of stuff. There's what's known as C5ISR, which is mostly communications and control, so any networking and communication devices. There's the Armament Center, which is obviously armaments. There's the Aviation Missile Center, Ground Vehicle System Center, and Chem Bio centers. And I hope I didn't miss one there. And so you get that those are the applied research centers for those particular areas. And the Army Research Lab is the bench level lab that supports all of those other centers. And so in the world of additive manufacturing, we didn't have a specific mission as in develop this material for this platform, for this vehicle, for whatever. It's more general across the entire Army enterprise, developing materials and processes to accelerate all of those things. I kind of give you an example. When I first started and I was working on armor programs, I worked on both vehicle and personnel armor. Sometimes the Army Research Lab's mission is 45 years in the future, 30 to 45 years in the future. And so if we're developing a new armor system, personnel armor system, we're designing an armor package for a soldier who's not even born yet, since most of our soldiers are, 17 to 25 years old. So if I'm working 45 years in the future, I'm designing for a threat that might not yet exist, and an armor package to defeat that threat for soldiers who aren't even born yet. So that's the kind of mission that we have at the Army Research Lab. It was a lot of just extremely interesting people, very, very brilliant folks that I worked with. I was very lucky to work with some just genius level folks, and working on future programs that I have started to actually become real. And now I see things with my friends that are still in the DoD using technologies that I helped, or my colleagues helped to develop many, many years ago. So in the world of additive, though, again, we're helping to support all of those different research or development centers. And so I built with the blessing of course of my chain of command, a research facility to conduct material and process development. So material development, meaning there are already people at the Army Research Lab developing new materials that have never existed before, right? So, literally if you saw a vial of it, that's the only vial that's existed on the planet ever, kind of stuff. And if that was going to be a useful material for the Army in the future, well, how do we scale up production of that material? And then how do we 3D print with it or additively manufacture with it? And then also taking current additive manufacturing technologies and manipulating them so they could process Army relevant materials. So that lab still exists. It's at the Aberdeen Proving Ground in Aberdeen, Maryland. And I was lucky enough to build that lab and operate it for several years before I left federal service.
And so during that process, this is kind of 2009, 10-ish, right? In that ballpark. So a lot of different technologies kind of ramping up. How were you were you just like, hey, give me one of each, or were you prioritizing specific technologies for use cases that you had either visualized down the road or things that you kind of knew were going on in other departments or groups?
So thanks, man. I feel like, just so your listeners know, we didn't plan this ahead of time, but you're asking me perfect questions. So around that time, 2010, 11, I realized that I needed input from those other stakeholders, those development labs, beyond just what I thought would be important in the future. Those labs that were developing technologies that were specific for their applications. One of those labs, I mentioned C5ISR for communication. At the time, they were called CERDEC. They were also on Aberdeen Proving Ground. And so we started this Aberdeen area additive manufacturing working group or something. That lasted 2 months before other organizations that were outside of Aberdeen, but still within our circle, were like, oh, we want to be part of this thing too. So then we went from that to the Aberdeen Interagency Additive Manufacturing Working Group, to the Army Research and Development Additive Manufacturing Working Group, to finally the Army's Additive Manufacturing Community of Practice. And so I was also fortunate to be a founding member of this community of practice, which has recently been changed, had a name change to the Army's Advanced Manufacturing Community of Practice, encompasses more technologies than just additive. But through that community of practice, we were able to convene all of the experts in manufacturing, future manufacturing readiness, 3D printing across all of those development centers, and then really get input from those stakeholders on what materials they needed, what technologies they needed for the parts that they were trying to make to support the systems that they were trying to support. From, again, everything from communication to soldiers' uniforms to food to ground vehicles to air vehicles, whatever. And so I'm happy to say that community of practice still exists. I'm now, since I've been out of federal service, I'm now an academic advisor to the community of practice, but and happy to still be part of it. But when the Army added we had the Army Materiel Command, which is what most of the Research and Development Command, or what's now called DevCom, was under, and added the Army's Futures Command, which is a new command in the Army, only a few years old. We were able to help the Army write the implementation plan for additive manufacturing, which is a big deal. So the Army, U.S. Army, is the largest organization in the world, I think, bigger than Amazon or Walmart, as far as I know. Don't quote me on that, but that's what I've heard. And so to implement additive manufacturing across the entire Army enterprise was something I'm very proud that I've had the opportunity to be part of. And so, yeah, to answer your question, the community of practice still exists, and they govern how to operate in between those agencies within the Army, and really decide on what are those next capabilities that are required, and what do we need to get there.
And I imagine it's such a complex problem, and even in small organization, to implement an additive solution, just because you can design a part that saves some money here or there, like the number of processes that are involved, from how do you procure it, who makes it, what are the technical data packages, how do you communicate who makes it, and all those other steps and testing and stuff have to be considered beyond, like, okay, we can make one and it works, but that scaling that across a massive organization must be a daunting task, to say the least.
It absolutely was, but there's a great group of folks within the Army's Advanced Manufacturing Community of Practice that really know the technology space and are just amazing to work with. And I'm glad I still get to work with them. Yeah, really smart folks.
Yeah. And so we're talking about kind of this kind of 2010s now. You stayed with the Army for 15 years. Was the next step after that directly into academia, or you kind of have some steps in between there?
Yeah, so I left federal service in 2018. Not really I didn't have any intention of leaving. It was just one of those things that kind of happened. But by that time, 2017, 2018, a lot of government prime contractors, those large government or large industrial corporations that, provide, vehicles or aircraft or whatever to the DoD, were really investing heavily in additive manufacturing. And I was getting, just because of my situation in the Army Research Lab, I was, getting some offers. And so I started thinking about leaving federal service. And at the time, I had some friends at the University of Delaware who were putting together an advanced manufacturing graduate program, or at least starting some grassroots effort to develop a graduate program in advanced manufacturing. And so I thought, if I was going to leave federal service, I really wanted to do some I don't know, what I consider STEM and outreach. I did a lot of that at ARL, working with students of all ages, and I love that so much, and I wanted to continue to do it. So instead of going to work for a large government prime contractor, I thought I'd go to a university first and test the waters. So I went to the University of Delaware, worked at the Center for Composite Materials under Jack Gillespie and Dr. Mark Morostik, and I'm telling you, just great folks over there. They have been the Army's Center of Excellence for composite materials for quite some time, and I had just a phenomenal time working there. While I was there, helping them build some research capabilities to be able to build an advanced degree program, I started hearing about Harrisburg University of Science and Technology and how they had created this undergraduate program in advanced manufacturing. And so I went to reach out to Harrisburg University to see if their undergraduate program might be a pipeline into the graduate program that I was working on at the University of Delaware. And after several, just conversations with Harrisburg University, they asked me to come over and help them build what they were trying to build. And it was a tough decision to leave the University of Delaware because great folks over there, but I just decided that I would come over here and help this small school who Harrisburg University, not well known in DoD circles just yet, but has some unique insight and unique advantages and as a small school. And so I decided to make the jump. I do also wear a couple hats. So as every good ex-government employee, I wear a few hats. Harrisburg University is my full-time job right now, and I'll tell you about that a little bit more in a minute. But I do also work for a company called Astro America, the Applied Science and Technology Research Organization of America, where I'm the chief of manufacturing for that organization, which is kind of a dual-hatted organization where they have a think tank and a research institute. And that think tank deals with public policy. They have some great programs right now going on called AM Forward, working directly with the White House on getting advanced manufacturing technologies to small and medium-sized enterprises across the DoD supply chain and the industrial base as well. So I highly encourage you to check out AM Forward. But at Astro America, I work on a project called the Jointless Hull effort. So Jointless Hull is, as far as I know, the world's largest metal hybrid manufacturing machine we're currently building. The team that's assembling that machine is Ingersoll Machine Tool leading the way, with Meld Manufacturing as the additive portion, and Siemens Digital Industries working on controls and automation. And that machine has a build volume of 30 feet by 20 feet by 12 feet. Yes, it's big and it's fun. So just, use your favorite search engine and look up Jointless Hull effort. And that large machine will be delivered to the Army's Advanced Manufacturing Center of Excellence at Rock Island Arsenal later this year, probably in the next 3 or 4 months. I also have been working with a company called Nscript for quite some time. Nscript's a capital equipment firm. My personal research, I know I didn't mention this yet, but my personal favorite research is in multi-material, multi-technology printing. So I want to print functional devices. I want to print sensors and communication devices, electronics, embedded into structure. I want to print multifunctional things, whatever that is. And the way that I've been able to do that successfully over the last few years is using Nscript technologies. So I partner with them on a lot of things. And I also am a partial owner of a small business that executes SBIRs, which are small business things. And I sit on the board of a couple additive manufacturing OEMs. And so
Then you sleep 1 hour a night.
Yeah, a lot of those things going on. But the good news is that all of those organizations know that the main driver is I just want to accelerate advanced manufacturing education and capabilities, and they're all for it. So they all let me just do my thing, and they're happy to collaborate through me, and I am too. So it all works out. So I'll tell you a little bit about Harrisburg University now that I'm here. It'll be February 15th will be my 1-year anniversary. So I've
Coming up.
just a little less than a year. Harrisburg University started an advanced manufacturing undergraduate program about 4.5 years ago. So we graduated our first class last May. Our second class will be graduating this May. Advanced manufacturing includes, for us at Harrisburg University, includes the manipulation of traditional manufacturing methods to either incorporate new materials or materials that are not traditionally used with those manufacturing methods, or to create new materials or new manufacturing methods. And so that's a very broad term for advanced manufacturing, but it really covers everything from casting, forging, welding, robotics, automation, additive manufacturing, composites, and the virtual realm around all of that. So we have an augmented reality and virtual reality or extended reality team that we work closely with to engage with training, and not just digital twinning, but actually immersive virtual environments in a manufacturing environment. So you could go in and actually, build something in a virtual environment before you actually build the real thing, and be immersed in that touch and feel. And so those things are very important to us, and that's kind of the center of the advanced manufacturing program here at Harrisburg University. The academic lead is Dr. Richard Pitts. It's a great academic. His background is robotics and automation, and we complement each other very well. My job here is focused more on the research side of things. So I mentioned we have this undergraduate degree already. We plan to offer a master's within the next 3 years and a PhD soon after that in advanced manufacturing. I think if we're able to do that, I think we'll be the only, if not one of the only, universities in the U.S. that can offer an advanced manufacturing degree from undergrad through a PhD. We, to complement this degree program and many others here at Harrisburg University, we've just completed building a brand new 11-story, 250,000+ square foot research tower in downtown Harrisburg. The advanced manufacturing program is the first tenants in our new building. We're filling that right now. You might have seen some of my LinkedIn posts recently about some new capabilities going there. So we have about 50,000 square foot of that new facility devoted to advanced manufacturing. We'll have our public grand opening in mid to late April, but students are already in there using the technologies. A couple of things there that I want to talk about. So Harrisburg University is young. It's a private school. It's only been around for about 20 years. We go about things a little differently than other universities. For instance, there's different terminology for the jobs around here. I mentioned Dr. Richard Pitts. He's the program lead instead of dean. We don't have tenure. There's none of that around here. You got to work to keep your job. We don't have a separation between the lab and the classroom. When I took engineering courses, especially in undergrad, I took classes, 2 to 3 days a week, and then had a separate lab. That lab, normally taught by a TA or a younger professor or another professor, and rarely did that lab ever coincide with the syllabus. And so we don't separate those things. We teach them together. So all of the coursework is actually taught in the laboratory. So students are taught theory while they're in front of the machine. So it's theory practice right in front of the technology. And I know that I learn better that way, and I see our students just grasping onto the concepts and running with them immediately by being able to practice the technology right away.
And what makes I've asked this to a number of guests, what are some of the characteristics that make folks successful in manufacturing, advanced manufacturing? I mean, from your perspective as students, like, are they people that like to work with their hands? Like, what are like the kind of characteristics that you see over and over again? Like, hey, like this person's going to do well, or kind of have kind of grasp on the stuff that's going on.
Yeah, I would say, 10 or 15 years ago, when I was interviewing young scientists or engineers, or even, potential interns or co-ops, I was really looking for those folks that knew how to turn a wrench. If somewhere in your resume it said you rebuilt your engine on your old Honda motorcycle or something, that's what I was looking for 10 or 15 years ago. Now there's such an overlap of areas of expertise that come into or advanced manufacturing in general. I have a lot of students right now who have an artistic background that are some of the best designers that I could ever even want to work with. I mean, they're just amazing. And you would expect maybe that their skill set would stop there, but many of them see a new design that they've created virtually, on their computer or whatever, and then they say, well, now I want to see if I can make that. Can you show me how to make that? And so some of these digital designers that I would consider more artistic have really, jumped out and said, now I want to learn how to make it too. At the same time, I still have students that love to turn a wrench. I mean, they come in with, machine oil and grease all over their clothes and their hands, and you're like, yeah, that's the person that I want to, work with me in the lab. And you get there and they excel immensely with their, hands-on activities, but they might turn around and say, I really wish I could learn how to design something. So I think it's just this broad spectrum from just everyone. I mean, we have students that are interested in food sciences, and they want to learn how to 3D print food. And you have students that are interested in forensics, and they want to learn how to 3D print things that they can use to represent what might happen in some sort of event that they need to use forensics in. Of course, in medical, our students that are interested in medical are highly interested in being able to reproduce X-rays or CT scans of a patient and be able to manipulate something with those designs that they make, or even to be able to create new medical devices. And so I think, I guess what I'm saying is that the type of student that appreciates advanced manufacturing has grown immensely, because it's not just the student, the young scientist or engineer, the young person that wants to do woodworking or modeling or building an internal combustion engine anymore. It's not that. It's every student that's interested in art and science and tech, and I don't know. It's amazing.
That's awesome. So as we kind of wind down the interview here, I always like to ask kind of more of a fun question. So over the time that kind of you built your career and have worked in a number of industries, what's a book that has made an impact on you and that you would want to share or have recommend that other people check out?
Yeah. So sorry.
Perfect.
Thanks. I didn't expect this question. A couple years old now, but my buddy John Hornick, 3D printing will rock your world. I know that a lot of people have read this before, and John's been around the block for a little while now, AMUG especially, and Rapid. But I got to tell you that I think this book is great. I mean, it's not high technology. It's not I wouldn't call it an academic book, but man, I tell you that there's a lot of really interesting things in there that just get your mind going about 3D printing.
That's awesome. Well, great. LJ, thank you so much for joining the show today. we'll put some links to all the things that you're involved with at Harrisburg and Astro America on the page when we release it. So thanks again, and thanks for all you do in the industry.
Thanks a lot, Mike. I appreciate it. Thanks for having me on.